Today we're going to be focusing on the isosceles triangle, and you just finished the construction of an isosceles triangle and you found some of the isosceles triangle properties. So let's just review what we saw. So in an isosceles triangle, first of all, it's defined as a triangle that has at least two congruent sides. So I'm going to mark my two sides. Let's say this triangle here, this isosceles triangle, has exactly two sides congruent. We know that the congruent sides are called the legs, and then the non-congruent side is called the base. The legs intersect at a point known as the vertex angle, and then there are two base angles. Now, when we looked at the construction of the isosceles triangle, we had our protractor there. We did notice that the base angles were congruent. Now, what we want to do is we want to say that that could be true for all isosceles triangles. So in order to do that, we need to prove it, okay? So what we're going to be looking at now is a little theorem called the base angles theorem. So copy this one down. We're going to go through the proof together. It's a little bit different than what you might be used to. Pause, and when you're ready to go, hit play. Okay, so here we're ready to go. This one does something a little bit differently, but we'll get to step 2 in a minute. Let's just look at our given information. So we know the triangle ADC is isosceles, and that AC is the base. So if AC is the base, I'm going to mark my figure with what I know. And I know that segment AD is going to be congruent to segment DC, because those are the legs of the isosceles triangle, right? So it's by definition of isosceles triangle, segment AD is congruent to segment DC. Now, something a little interesting happens here. If you look at step 2, now this is not something that I'm going to hold you responsible for doing on your own, but it's great to see the development of this proof, okay? And you'll notice that the book does it just slightly differently, but we use the construction of an auxiliary line. So what that means is that we're going to draw in a segment and call it segment DB, such that segment DB is bisecting AC at the point B. Okay, so we are going to be just drawing in a segment DB so that it bisects segment AC at point B. Now, isn't that nice that we could just do that? Yeah, well, sometimes we could do that in math, right? We think that we could just make things up. But because it does have certain properties, if that segment is bisecting segment AC, then we know that B is going to be the midpoint of AC because it's a segment bisector. And if B is the midpoint of AC, we can write in our statement exactly what we drew on the sketch, which is that segment AB is congruent to segment BC. Okay, and that's by definition of a midpoint. Now let's go back up to our sketch and see what's going on here. Remember, you always want to keep the end in mind, right? So in the end, we want to prove that angle A is congruent to angle C. Okay, those two angles we want to prove congruent. Now right now we don't know anything about angles. We're really focusing on sides. We have these two sides congruent and these two sides congruent. Well, since we don't really know anything about the angles, and we drew in this segment, there's a reason why we drew in segment DB. It divided the original isosceles triangle into two triangles. Now focus on those two triangles. Pretend, these are two separated triangles. What do you know about those two triangles? Well, you can see that you have two corresponding parts already congruent, right? You know that AD is congruent to DC and segment AB is congruent to segment BC. Is there anything else that you know? Yeah, we know that DB is congruent to itself, right? That's the reflexive property. If DB is congruent to itself, now look at what you have. You have side, 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 and side, side, side. So what does that prove? Well, that just proved that these two smaller triangles are congruent. And we know that if two triangles are congruent, then all of the other corresponding parts are also congruent. So then that would include angles A and C being congruent. Okay, so now let's write that up. Now that we talked through it, let's write it up. So we saw that the two sides were already congruent. So what we're going to say next, I have to scroll down here, through the reflexive property, segment DB is congruent to segment DB. Now, if I look through my proof, you want to make sure that you have all three side equations or congruencies listed. So there's your first one, your second one, and your third one. Therefore, you can now prove the triangle's congruent by the side-side-side postulate. And if the triangles are congruent by side-side-side, we know that through the corresponding parts of congruent triangles, we know they're congruent, so angle A is congruent to angle C. So what we just proved was the base angles theorem. Copy down this theorem. It says that if two sides of a triangle are congruent, then the angles opposite them are congruent.